So let's look at another example. We're doing comparison between different options and see about calculating the internal rate of return on an option where we don't have a rate that we're given. So this is the example for the parking rate. Okay, the parking permit that you actually can do is you can buy it in an annual, where it goes from August all the way through the entire year. So August 15, and the cost at that point is you buy it at one time is $180. And like in most cases, when you actually don't pay it all off at one time or pay it beforehand, you can give you an option where you can pay it over time. But as you pay over time, the cost goes up to you because they're charging you some embedded interest in now. So what you can do is pay by semester, and that would occur in August and in January. And at each point it is $130 each for each time. Okay, so the question that we have, what is the internal rate of return of buying, say, the permit? Okay, so if we look at it, let's just write as a timeline. Let's do a different kind of timeline. Let's don't do our ones and zeros, but let's just put down the months of the year. So what we have is we have something that looks like this. We have one option, option 1, where we have $180, and option 2 we have where we have to pay it off in sort of 2 installments, $130 in August and then again $130 in January for it. So what we know is from equivalence that these two are equal to each other. So we know that the net present worth of, say, the annual is equivalent to the net present worth of the semester. So what we have here is that we have these are $180 for the annual. We then have, for this one, we have the net present worth is $130 for the first one, and then we have $130 which is in some kind of time period away, which means it's we're at 5 months, if you want to think about that, 1, 2, 3, 4, 5 times away. So when we have this, we find out that the P given an F at some kind of I for 5 is equal to a factor of minus 50 over minus 130. Notice if we just move the 130 over, it comes a plus 130, so it makes that a minus 50. Divide by minus 130, we get that factor. So when we do the internal rate of return, we see that we have something that's equivalent to like 21.06% for this one. So you can see it's rather big loan. Now this one right here, we're actually doing is calculated in months. So if I asked you to do the effective, so IA in this case, the IA would be 1 plus this 21.06, and if this is in months, since this is in months, we're going from one month to the next month, like August, September, then that means we have 12 compounding periods in this period. And the formula for doing that would be equal, raise it to the 12th power, and we would finally come up with something like 891% effective rate. Rather large for doing financing, isn't it? Almost as like a loan shark would actually charge you for it. Now let's do one more thing for it. Let's look at it in a different way. Let's look at it and put down the months down into a column form, and let's say we have option 1 here. Option 1, we spend $180 in August, and that's it. Option 2, we spend $130, and then in January we spend $130. Well, notice what we actually can do here. We can just, instead of taking these two together, we can just do a little formula. We can just add them into the same, combine them for the time periods. So let's just do this. We're just going to subtract 1, and we're going to take 2 from 1. So in this case, you can see the result would be a minus 50. All of these would be 0, and this would be a plus 130 for it on this one. Okay, so what we have is then when we have a net present worth, we can actually do of the 1 minus 2, which is equal to, we have minus 50, and then some period away, 5 periods away, we have a plus 130 in here. And so if we do the p given an a, I, 5, and we solve for this one, we see we come up with 50 over 130, which is exactly the same thing as a minus 50 that we had up here of minus 50 over 130 that we actually have for it. So it actually does change out to be exactly the same for it.